Alright, picking up where we left off from the last video, if I want to find my position at 3, I can start off from 2, which we found from the previous term. At t equals 2, we see that this car will be at mile marker 1, and then he'll go at a certain increasing velocity from 2 to 3. And if we look at the area, we see that between 2 and 3 minutes, this car will cover 3 miles. Okay, so I'm going to let the area represent miles. So he'll cover distance of 3 miles. So if he starts off at mile marker 1, and then in 1 minute he goes 3 more miles, then it should make sense that after 3 minutes he'll be at mile marker 4. Okay. So to find his position at 4 minutes, his previous position is at 4, and then from 3 to 4, he's still moving in a positive direction, still above the x-axis, but now this car is slowing down. Okay, slowing down, and we see that the area is only 2, so he's only covering 2 miles instead of 3 from the previous because he's slowing down, and so, but he covers 2 more miles. So previous, he's at mile marker 4, he covers 2 more miles, so now he's at mile marker 6. So now these order pairs represent his location at these moments in time. So at 1, at time t equals 1, he's at position 0. T equals 2, position 1. T equals 3, position 4. T equals 4, position 6. Okay, so part D says state the absolute extrema and the x values where they occur. So we see that the furthest left, he's going to be, the minimum will be at mile marker t equals 1, because he moved after going backwards opposite direction for 1 minute. He's the furthest smallest mile marker he's going to reach is at mile marker 0. And then he's after 1 minute, he keeps moving in the positive direction, and so the largest x value, or the absolute extrema, we think in terms of mile marker, will occur after t equals 4, so mile marker 6. Okay, so part E, find the total distance traveled from 0 to 4. So think about how much distance is covered in terms of the odometer on in the car. So so he's going to go 1 mile backwards, 1 mile forward, 3 miles forward, 2 miles forward. So total, he's going to travel a distance of 7 miles. Okay. Find that this total displacement from t equals 0 to 4. So total displacement is simply how far he travels from his original point. Okay. So we can keep track of the negatives and positives here. So he starts at mile marker 1, he goes backwards to 0, goes back to 1, and then up to 6. So the distance he's traveled from the beginning point, the displacement is simply the 1 and negative 1 cancels out, so it's just going to be 5. Okay, part G, on the interval between 1 and 3, is the speed increasing or decreasing? So we can simply, this goes back to what we learned from first semester, we can simply compare the signs between f prime and f double prime. So we created a sign line in the beginning, and I'm just putting these two sign lines up below. So if we compare the sign lines, we see that between 1 and 3, okay, between 1 and 3, both f prime and f double prime is positive, so we know that we have increasing speed, same signs, because f prime is greater than 0, f double prime is greater than 0. On the interval between 0 and 1, is the speed increasing or decreasing? So between 0 and 1, we see that there's opposite signs, so decreasing speed. Okay, part G, using the data from A, B, and C, sketch the graph of f of x below. So from C, we found all the ordered pairs, right? 1, 0, 2, 1, 3, 4, 4, 6. So first thing we do is we can just go ahead and plot those points. Okay. Oh, and also 0, 1. Okay. And then, based off of the slope and concavity, we can create our graph. right? So decreasing, increasing, all the way to 4, 6. And then let's match the concavity, the curvature. So from 0 to 1, we want concave up. From 1 to 3, we want concave up. So 1 to 3 is always going to have this shape, concave up. But then from 3 to 4, we have concave down, but still increasing.